Okay, well, let's continue and talk a little bit about the quotient rule next in this video. So it says here that if f and g are both differentiable, then the derivative of f divided by g, or f of x divided by g of x, is equal to g of x times the derivative of f of x minus f of x minus the derivative of g of x all over g of x squared, or just f over g prime is equal to f prime g minus fg prime over g squared. So sometimes, or at least my old calculus teacher told me that an easy way to remember this rule is that the derivative of the quotient is low times the derivative of the top, or low d high, minus high times the derivative of the bottom, or high d low, all over low low, or low squared. So quite a rule to find a quotient. It seems like it's much more difficult to find a derivative of a quotient of two functions than it is to find the derivative of a product. Let's see why this is. We'll go ahead and derive this rule. So what we're trying to find is the derivative of one function divided by another. So what we're going to do is we're going to go ahead and let's let q of x be the quotient function. So q of x will be f of x divided by g of x. Because if that's true, then we'd like to know what q prime of x is, right? But if you kind of think about this a little bit, you can see that I can use the product rule on this one. So let's look at just what f of x would be. It means that f of x is going to be equal to, let's see, if I just cross multiply on what q of x is, it's going to be q of x times g of x. And the idea behind the proof here is that if we find what the derivative of f of x is, it'll be a function of the derivatives of q of x and g of x, and hopefully we can solve for the derivative of q of x in the resulting expression. So let's go ahead. So that's the strategy. Okay, so off we go to the races. If we have f equal to q of x times g of x, and f prime of x, it's going to be the first, q of x, times the derivative of the second, g prime of x, plus the second, g of x, times the derivative of the first, q prime of x, right? And again, here the idea is that what we're after is that guy, right, as a function of g's and f's. So the first thing we could do is we could replace q of x with what we know it to be. So q of x is the same thing. If we go back up here and sort of remind ourselves what that is, q of x is the same thing as f of x over g of x, so I can replace q of x with f of x over g of x. Let's do that first. And we get to this expression, and again, the whole idea here is that all we want to do is solve for q prime of x, and if we can solve for q prime of x, we'll know exactly what the derivative of the quotient is supposed to be. All right, so think probably the good place to go here is, I guess, to first subtract. Let's subtract this piece from both sides, and we'll end up with f prime of x minus f of x over g of x times g prime of x, and that will be equal to g of x times q prime of x. I guess the next thing to do then would be to divide through by g of x, and we'd get what? If we divided both sides through by g of x, we'd end up with prime of x all over g of x minus f of x over g of x quantity squared times g prime of x equal to q prime of x. And now it's just a matter of cleaning things up a little bit. Let's reverse the order in which we're writing. Let's put q prime of x over on the left-hand side, and on the right-hand side, I guess we would get, if I multiply, let's see here, if I multiply this guy top and bottom by g of x, then we'll have a common denominator and be able to add them together. So that first term then would turn into g of x times f prime of x. And then the second term, it looks like, is minus sign in between them, be f of x times g prime of x. And then we'd have this whole thing over g of x quantity squared, which I guess shows us the rule, right? That means that the derivative of q of x, and remember q of x is just the same thing as f of x over g of x, is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And that's it. That's the derivation of our rule for the for the quotient rule, which says that the derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, we've got two new rules. In my next video, I'll go through a few examples of how to use both the product and the quotient rules on actual functions.